The goal was to add support for Wave-in-a-Box for browsers that didn't have native WebSockets. And I had a couple of options, and I chose Socket.io because it had it was basically designed to add an API that's very similar to WebSockets, but support over transports that weren't WebSockets. So the API is very similar, has the same semantics, a little bit different functioning though. The data transport is very similar, but there's some additional support in that right now with WebSockets, if you log in and you have no activity, it'll just disconnect you after, say, 5 minutes or less. With Socket.io, there's some heartbeats going back and forth so that the connection will not drop due to inactivity. Right now, there's 3 server implementations. The Node.js implementation, which is officially associated with the Socket.io JavaScript, and then someone wrote a server in Go, and another one wrote a server in Ruby. None of those, of course, would work for us. So I created the Socket.io Java project. It's a J2E servlet-based implementation using the Jetty WebSocket component and the Jetty continuations, which was needed to do an efficient non-multi-threaded method of communication. Because if you've got like 10,000 clients, you don't want 10,000 threads. You want 10,000 socket connections and the number of threads needed to support whatever it is they're actually doing. Otherwise, it's not scalable. So I did make some I did fork the original Socket.io project because I needed to make some changes to really make it work well with Wave-in-a-Box. I changed the message encoding slightly to support some other semantics. I should also mention that I created this as a separate project because it has applicability outside of the Wave-in-a-Box. I wanted to make sure it would work with Wave-in-a-Box, but I also wanted it to be an external project so that other people could use it for other purposes. I added a clean close semantic because with the original Socket.io implementation, you called disconnect and you had no way of knowing if the last message you sent actually arrived at the server without implementing your own acknowledgement stuff on top. With this, when you call close, you'll get a disconnect message indicating exactly what kind of close was achieved, whether that was a clean close or whether or not your connection dropped somewhere along the way. It's not as good as true acknowledgments, but at least you'll know whether or not your close was successful or not. I also added more detailed information to your disconnect so you know what kind of disconnect occurred, whether or not the server initiated a disconnect or if you just lost your connection entirely or if there was some unknown error. And I did some minor bug fixes and changes as well. And unfortunately, right now, it is not compatible with the official Socket.io implementation, so you can't use his JavaScript with my server. You have to use this JavaScript that's served from my server. Socket.io supports 6 transports. There's the raw WebSockets. There's the Flash-based WebSocket implementation, HTML file, XHR, which stands for XML HTTP request, multi-part, long polling, and JSONP long polling. For the WebSocket, obviously you've got Chrome 6+ support, Safari 5, I think, outside of the iPhone universe because they went with the version just prior to the addition of WebSockets. And I don't know if Firefox 4 works with raw WebSockets. I think some people managed to make that work. Now, the Flash-based WebSocket will not work behind a proxy. There's in the Flash implementation, there is a way to tell it what proxy to use and what username and password to use, but it's not really usable in a generic environment because the browser needs to know about the proxy information, and that basically requires prompting the user for the information, and most users don't know what that is. Most non-technical users, anyway. See, on the server side, the WebSocket implementation on the server side is basically the same, although it does go through a different URL, and the server serves up the Flash component. HTML file is really there's 2 classes of non-WebSocket transports. There's a persistent connection and a non-persistent connection. Unfortunately, none of them have persistent send, but they all have persistent get. So with HTML file, you're basically implementing the client calls get, and then the server just strings messages over them as required, and the connection doesn't close until the session ends. So with this we're using the chunked transfer encoding, which is basically the amount of bytes and then the bytes being sent repeatedly. There's a little bit of overhead in the messages in that what's being sent is actually a script tag. On the client side, though, it cleans them up so you only have one script tag at a time in the HTML document, so it doesn't max out your memory over time. Going from client to server, it's a simple post message where you can have one or more messages encoded in a block and then pushed. And because it's a plain text, there's not a lot of extra rigmarole you have to go through to translate from the client side to server side. XML, the multi-part, on Firefox, XML request supports multi-part transport. So the server is basically specifying content type of multi-part X mixed replace, which I'm not completely familiar with, but basically it means that each multi-part replaces the previous multi-part, so you don't end up growing your document over time. So the different encoding, the boundary that's specified is right now it's a random 20-character string. So there is a small chance that random 20-character string plus the previous two dashes is going to appear in the actual content. If that happens, that message won't make it through. But because it's a random 20-character string, the chances of that happening are fairly small. We would need, in order for absolute bulletproofness, we'd have to add some sort of encode-decode for that one rare case. Right now, that's not dealt with. And again, the client to server is post. And in the JavaScript, if a post is active, then the messages are queued up until the post completes, and then it pushes an entire block of messages. So if you're just cramming messages down the pipe, each post will contain multiple messages. Long polling. This is the most common transport we're familiar with before. The get will timeout eventually. Right now, the timeout is 20 seconds because most browsers have a request timeout of 30 seconds. So we want to make sure that we get an empty reply versus a connection timed out. And there's no need for any sort of special encoding, so it just sends the message box plain. And again, the server side is post messages. And then JSONP polling, I'm told, is really only needed for doing cross-domain and IE. I'm not sure what other browsers might require it. The client is basically pushing JavaScript method calls, and posting apparently requires using a form in an iframe, and the data has to go through this form URL encoded stuff, so some decoding has to happen on the server side. The messages are encoded in a block where you use a little tilde between the pieces. You've got the message type, message size, and then the data. Message types, the very first message the client gets when it connects is the session ID, and it uses that for further connections. So for WebSockets, it doesn't really matter, but for all the others, the server needs to know which session the connection is associated with. As a close message, ping pong is for your keeping your session liveness, so the server will periodically send a ping, and then the client has to reply with a pong within a certain time, not otherwise the connection's dropped. And then you've got your data blocks. The API does support the idea of a message, basically an inter-indicating message type, so that you can makes it easier for you to have multiple message types going back between client server that the software itself doesn't need to know about, but your client software can switch on. For the future, we're planning on standardizing the client-server protocol, because right now it's all you have to look at the code to figure out what they're doing, but I'd like to at least have a document so that anybody can implement a server or a client based on that standard. I want to separate the handshake for session from the actual connection and make it a little bit easier to implement some alternative authentication forms. And right now, the server has intimate knowledge of how the client's JavaScript is implemented. And I want to separate out. There's a document written by Michael Carter describing something he called a comment session protocol. And one of the ideas he had in there was this ability for the client to specify what the preamble and pre and post block stuff was. So, for example, that script tag stuff for HTML file, the client would say, here's what I expect before and after the actual message data. And then the server just passes that. It doesn't need to know what it's dealing with, so that the client has the server becomes independent from the client in terms of implementation. So if the client decides to change the name of the method that's in the script tag, the server doesn't need to know that. The client just tells it during the session establishment, and then the server just feeds those pieces around the block of data. And there's also plans to converge the existing socket.io project, the core project, and the stuff that I've done, so that he can pick up the improvements. But we're still in discussion on that. I'd also like to, there's no test cases right now. I've got some simple test applications to make example applications that I can use for testing, like a chat, a echo, and broadcast. But I need to add some formal test cases so that you can do a lot of unit testing without having to start something up and type in it. Same browser tests will be a little bit more difficult, but I do want to have something so you can just basically point your browser to URL and have it run the tests and tell you which one's passed and which one's failed. Make it a lot easier to go through all of your browser tests. And I believe it's also going to be possible to add support for other serverless containers. For right now, I do know that this code should work in Tomcat 6, the latest version, but the WebSocket will not work, but the other stuff will. I think that's. Oh, and here's the projects that are involved. You've got the original Socket.io project. He's got his own Socket.io web page and the GitHub source code project. And you can add a dash node here to get to the node.js project. And he has links to it in there, so it's easy to find. WebSocket.js is the Flash-based WebSocket project. I should point out that right now he only supports version 76 of the WebSocket protocol. The new ETF Draft 3 isn't supported. Jetty added support for that in their 7.2 version, but I don't support that yet either because they changed the APIs. The next one, the Socket.io-fork, that's the forked version of the Socket.io code that holds the changes I made. And then Socket.io-Java is the Google Code project that holds the Java side. And the Flash and the Socket.io JavaScript that's served from the server is contained in this project as well. So you don't have to get the other project to make them work together. Any questions? Yes?
On the proxy, you had said you were not going to do that because of prompting for user passwords.
The Flash base doesn't work through proxy, but everything else does.
Oh, just Flash?
Yeah, just Flash. Because the difficulty is that there's no way programmatically for JavaScript or a Flash component to query the browser for proxy information. No browser provides that information to you. You can't ask what proxy are you talking to, what's username and password do I need to use. None of that's available. So in order for the Flash to get through a proxy, you have to explicitly tell it in code, here's the proxy, here's the username, here's the password you have to use. In order to do that, though, you have to query the user to get that information. So the Flash-based WebSocket won't work through a proxy without a lot of rigmarole that's really not appropriate in a generic user environment. Now, in a fixed enterprise environment where that information is can be hard coded into into the code, then you can prompt the user for their username and password again, and then that would work. But that won't work for most cases. Everything else, though, does work through a proxy. I've tested it.
So, sorry if you mentioned this. Does it automatically? So if it's not working. We can't establish a connection through Flash. Will it just automatically gracefully degrade?
Yeah, it'll fall through. Usually, if things are poorly configured, it'll fall through to the XHR polling.
Okay. Does it take a while to do that? Okay,
in Chrome, things connect right away. In Firefox, it does take. It seems to take 3 to 10 seconds to establish a connection. And I don't know if there's any way to speed that up. If you know for a fact that you're never going to use the Flash stuff, you can modify the project to just tell it not to even consider Flash and just skip right on through, and then the connection should happen a little bit quicker. But it does work through. It checks to see which transports should work based on whether or not you even have the WebSocket API, and it'll try those first. And if it doesn't find them, or I think in the case of WebSocket, if WebSocket fails, it won't fall through. But in the case of Flash, it will fall through. Any other questions? Okay.